Okay, folks, we are going to look at a paper that computes mortalities associated with heavy rains and floods in Mumbai, especially when combined with high tide levels, high tide, low tide, etc. Typically, these papers have a news and views kind of article associated with the main paper. And this one is written by our good friend Subimal Ghosh, who describes the main results and talks about how heavy rains in Mumbai are basically arbitrary, seem arbitrary if you look at the statistics, and no pattern emerges when you look at the statistics or the data period that's available, which is quite substantial. And he raises the issue that this kind of arbitrary and patternless rainfall distribution, extreme rainfall, makes it very difficult to predict, because he's leading some efforts on actually giving early warnings for Mumbai floods. But the paper itself focuses much more on the health aspects of floods. People talk about forecasting floods, managing disasters, preparing, responding, preventing, and recovering from floods, and so on. This one wants to focus on mortality. Apparently, there are papers on urban floods and mortality, but they haven't covered Indian cities, so this one is focused on Mumbai, where they've got some data. Mortality impacts of rainfall and sea level rise in a developing megacity. We'll mainly look at the figures, because the main message I want to give you is that there are clear signals that floods bring death, and they are very high for exceedances or increases in number of deaths above average is very high for children below the age of 5 and people over 65, and women suffer mortalities much more than men. Okay, so let's read the abstract and then look at figures and some discussion. Rainfall and flooding frequency disrupt the lives of urban residents worldwide, posing substantial public health risks. Rapid urbanization is exposing larger and more vulnerable populations to flooding, while climate change intensifies rainfall patterns and rising sea levels impair drainage systems. All these cities, Mumbai is quite an old city, much more than a century old, and the drainage system was built a long time ago for some rainfall rate like 25 millimeter per hour, and now you get hundreds of millimeters sometimes. Obviously, system cannot handle it. Populations have grown, garbage and blocking have grown. There are systematic efforts to clean out the drainages before, but retrofitting them is not always easy, and so on. Despite the growing recognition and urgency of these hazards, the health impacts of rainfall remain poorly understood, and those of sea level rise are entirely unquantified. Here we estimate the mortality consequences of rainfall in one of the world's largest cities, Mumbai, India. We integrate high-resolution data on rainfall, tides, and mortality to analyze how unmanaged rainfall and its interaction with tidal dynamics contribute to urban health risks. We find that rainfall causes more than 8% of Mumbai's deaths during the monsoon season, and that more than 80% of this burden is borne by slum residents, what we call informal housing, but slum is the right word. Children face the biggest increase in mortality risk from rainfall, and women face a greater risk than men. Essentially, to do this, you have to take all-cause mortalities and then look for excess deaths, and then try to relate them as locally and as accurately as possible to rainfall events, which is what they do. I won't go into the details, but these are not easy tasks in terms of squeezing out the signal, separating the mortality caused by the extreme rainfall itself versus all other causes that tend to anyway elevate deaths during the monsoon, as we will see. Our findings reveal that mortality impacts of rainfall are an order of magnitude larger than is documented by official statistics, highlighting the urgent need for investment in improved drainage, sanitation, and waste management infrastructure. There is no question about this, so that's the main message. But the idea of estimated mortalities being an order of magnitude larger than reported deaths often relates to the fact that it's not always easy to attribute deaths to particular events, so they just tend to be recorded as normal deaths. Okay, so there are numbers on how unmanaged rainfall is exposing more and more people to floods, and sea level rise will increase and will bring more challenges to cities on coastlines like Mumbai, Chennai, Kochi, etc. And the literature on generally urban flooding, adaptation, early warnings, and so on keep on increasing, but there is limited understanding on how rainfall and sea level rise actually translate into health burdens. So easing these burdens requires addressing two major challenges. First, as rainfall is often highly localized and its effects unequally distributed, rich, poor, young, old, men, women, etc. Analyzing its health impacts demand detailed within-city data on exposures, vulnerabilities, and health outcomes, especially mortalities. Secondly, statistically disentangling the effects of rainfall from other correlated factors that also influence health is always complex. Okay, so we will see quickly that the results, there is a lot of statistical analysis involved in actually disentangling rainfall, heavy rainfall related deaths from other factors that occur during the monsoon season as well. But you can see that if you look at rainfall from June to December, death rates, so they'll be per 100,000 or so, you can see as annual rainfall increases, the number of deaths during June to December increase. And here they are comparing the death rates for different age groups, less than 5, 5 to 64, and 65 plus, compared to the January death rate. You can use any month as the baseline to look for exceedances in death rates. So you can see that they all increase during the monsoon, but the fastest or largest increase is for children less than equal to 5 years, and 5 to 64 see an increase, but not as sharp as the elderly. Greater than 65 actually drops during the milder months of weather, even in Mumbai, and then it increases more than the other more than the 5 to 64 during the monsoon. And you can see particular days here. This is the 3rd August 2007. Some heavy rain happened here. You can see the daily rainfall and number of pin codes within the city that got covered by the rainfall, mostly in the southwest here. And if you look at 30th June 2007, some very heavy rain happened, even more than 300 millimeters during the day. And in fact, this region didn't get as much, but this large region got heavy rainfall. There are hills here, local orography, and lowlands here, and so on. So you can see average rainfall across these pin codes and rainfall range across pin codes in millimeters, both in millimeters. You can see that June 2007 is a monster in terms of the rainfall across the pin codes, and also average rainfall across pin codes it was way out there. So obviously a very, very heavy extreme rainfall event. And if you look at the impacts on deaths, as daily rainfall increases, percentage impact on deaths increases. This is the 95th percentile confidence level. Okay, and the deaths don't just occur during the flood. They can last for weeks because there are various causes: electrocution and loss of wage, apparently, because they lose jobs during such heavy rain events, and you can have loss of food and unclean water, and of course you have diseases like dengue, malaria, diarrheal diseases, and so on. So impact on deaths percentages, depending on the rainfall rate, it increases during week 0 of the heavy rain, obviously, but even during week 1, it's there, lower, but it's still very much there. Week 2, it continues, maybe a little bit lower, but week 3 and 4 are almost similar, but maybe even a little bit of an increase here, even though the spread here is larger as well. So essentially, the flood is not done when the waters recede or go away or driven away by pumping them and so on. In fact, the aftermath of the floods continue to kill people, and that's something that must be taken into account in terms of health impacts. Okay, so this is unequal mortality consequences of rainfall across population groups. You are again looking at impact on deaths for stratified age groups below 5 years old, 5 to 64, and 65 plus years old. There are some details in terms of all population, and so let's read that a little bit here. Impact of daily rainfall on deaths by age group. The sample size is almost 58,000, more than 58,000. B, impact of daily rainfall on deaths for slum dwellers and non-slum dwellers, age groups, and then female and male. But here, let's read the spread. Impact of daily rainfall on deaths by gender. Points along each curve represent the percentage change in 5-week mortality due to a single day. Mortality due to a single day with total rainfall value shown on the axis. So single day rainfall and then 5 weeks of continued mortality impact, so they are accumulating over those weeks. Shaded area indicates 95% confidence intervals, whereas solid lines denote point estimates. The dashed black lines reproduce the point estimate for the population-wide average mortality effect. So if you look at the 5-year-olds, it's very high compared to the population-wide. And for 5 to 64-year-old, they are almost similar, so they are not heavily affected. 65-year-olds do increase, see higher mortality here, and it's a bit more complicated, but you can see here that their mortality rate jumps as well. Okay, typically it's lower in terms of deaths relative to January, even for the 5 to 64 range. So there are some details that have to be figured out. But nonetheless, if you look at impact on deaths in percentages again of rainfall over weeks after the one-day event, it's much lower for non-slum dwellers compared to slum dwellers. And for slum dwellers, it's higher than the all population deaths, and similarly impact of deaths on high elevation people and low elevation people. Low elevation people is higher, these are slum dwellers, higher in both high and low elevation, but for high elevation, for non-slum dwellers, I won't call them rich people, but let's say they live in pakka houses or hard structured houses, that drops here, but also increases for them when there is low elevation, but slum dwellers is higher. And of course here you can again see females experience significantly higher impact on deaths in percentages during the flood and following the flood weeks. Okay, there are some details here, and some additional material is provided in the supplemental material that you can look at. To read off some of the discussions, using the estimates presented in figures 2 and 3, we calculate Mumbai's excess mortality from rainfall during our sample period. So they're looking at something like 2006 to 2015 for the analysis. Excess mortality of 7.3 to 8.6% of Mumbai's total deaths in an average monsoon season during 2006 to 2015, depending on the model used, representing approximately 2,308 to 2,718 lives lost in each year's monsoon season. So they use an econometric model to do these, basically use statistics, use socioeconomic factors and other confounding factors like age, gender, kind of housing, etc. Okay, so our results are qualitatively robust under a variety of empirical specifications using alternative non-parametric controls for baseline mortality statistics, which I'm going to skip. So they also try to give you kind of a cost of such mortalities. Applying an India-specific estimate of the value of a statistical life of US $1 million, this probably comes from the World Bank estimates. So this is value of life years lost. Our results, so if you die at some point and you are going to live to an average of plus X years, then you compute the life years lost and put a value on it. Our results imply that the mortality costs of rainfall in Mumbai are approximately 1.2 billion US dollars per year. This value only represents the mortality costs. Overall welfare impacts would consider many other damages from rainfall and flooding, including morbidity and economic impacts. Morbidity is that you get sick, maybe you won't be able to work, and so on. However, the excess mortality costs of rainfall are probably a substantial and largely unaccounted component of total costs. Our estimates of these annual costs for Mumbai alone are the same order of magnitude as India's total annual direct economic damage from flooding. Many numbers are put out there, but ultimately it's a risk. You have to deal with it, with adaptation, health care, and services in terms of transportation and access to hospitals, etc. Right? Impact on deaths. So hourly rainfall here, amplified mortality impact of rainfall during high tides. So this is the impact on deaths, and you are looking at tides and then hourly rainfall for a particular season, 2007, going from 29 July to 3rd July, and you can see that high tide rainfall adds, it's only about 30 millimeters, so it's not hundreds of millimeters, but you can see that the tide is 400 centimeters during that time, so you can see how the two can combine, and you can look at that again on impact on tides. So when the tide is low at 94 centimeters in the 5th percentile, you can see that the impact on deaths goes like this. This is the dashed line here. These are point estimate. Dashed lines reproduce the point estimates from A here. So there is some way of making sure that you are tracking both estimated deaths at low tides versus all deaths. 50th percentile, so 262 centimeter tide level, and you can see both are similar in terms of solid lines denoting the point estimates and dashed lines denoting the point estimates from A. So this is the overall, and then out of that they both agree here, but when you look at 95th percentile, the 416 centimeter tide, you can see that these estimates are much lower than when extreme rainfall happens during high tide. Okay, so total deaths are lower during low tides than the average estimated here for all tides, and this is similar when you are in the 50th percentile, but for high tides, mortality or death impact on death is significantly higher, even though the 95th percentile spread is higher. Okay, so this is just looking again at monsoon season deaths, total deaths, and then age groups. This is for all groups, and non-slum and slum, and female and male. You can see clearly non-slum people die much less than slum people, but here children die much more than 5 to 64 age group, and 65 plus also die more. If you look at the same thing, let's read the mortality burden, rainfall, and future sea level rise. So it's looking at monsoon season deaths and additional deaths due to sea level rise. So here time of day for June 2007 and tide height. So sea level rise going from depending on which tide phase, high tide, low tide, and so on, you can get different numbers. So these are all deaths, and deaths caused by rainfall, and you are obviously rainfall is adding, and then tidal levels are exacerbating rainfall related deaths. Okay, I'm being a little bit lazy, but you get the point. Okay, so they talk about some caveats in the way they do these calculations. Several caveats to our analysis are worth noting. First, our rainfall data make it difficult to capture mortality impacts that may occur over very long time scales, that is longer than 5 weeks, because the measurements of local rainfall are only available for a portion of the year. So typically rainfall measurements go from, I think, May to October. Accounting for these long-term effects may result in larger impacts estimates, etc. And secondly, although our analysis captures all-cause mortality, the individual level mortality records do not report the cause of death, precluding us from fully understanding the exact pathways through which rainfall imperils human health across the urban subpopulations. That's always tricky. This is why the reported numbers by the government can appear lower than numbers estimated this way, because they don't have the resources to sit down and do the attribution and separate deaths into rainfall caused, delayed rainfall caused, rainfall related health causes, and so on. So they just write the most obvious ones like electrocution or drowning as flood related, or rainfall related, others as just deaths maybe. Okay, so I will leave it there. It's a good paper. You can go and read more if you're interested, but I just wanted to include a brief summary to say that there is a very clear evidence that extreme rainfall, there is an increase in mortality during the monsoon anyway, but extreme rainfall adds to this, especially for children younger than 5 years age and people older than 65, and women die much more than men. Total 8% accountable for rainfall related deaths during the monsoon season. Okay, let's leave it here.